All right, so here's our problem. It's a truss, and you'll notice it says determine all the forces in the truss. So we have a little bit of work to do. How would you like to proceed first? Would it be...
Free body diagram.
Yeah, free body diagram. Good call. Free body diagram is always a good response. Should we draw one for the whole structure and maybe try to find my reactions at E and D?
Yes.
I think that's a wonderful idea. So let's do that. So I'll come over here and draw a free body diagram that looks something like my truss. There's only one load applied up here at F, and that's 100 kips. And then I'm going to assume reactions at D and E. So what do we have at D? Looks like a roller. So it's free to move in the horizontal direction, but not in the vertical. So I'll call that dy. Then over here at E, it's a pin. That's about midway. So that would be EY, and then I'll assume in the X direction, EX. And let's see, this total height here looks like 30 feet, and then these are 20 feet. I think that's enough information there. So what should we do first? How do we find our reactions?
Some moments about E.
Yeah, that's a great idea. Let's do that. So let's sum moments about E. Remember, the strategy is always, not always, but it's a good idea to look at the pin, because we know that this pin, in fact E, two of our forces are concurrent at E, so that's a good place to start. So summing moments about E, and I'm using right-hand rule for my sign convention, dy creates what kind of moment about E? Positive or negative? Positive. So I'd have dy as the force, and the distance from E to D looks like 20 feet. And then about E, the applied force, the 100 kip force, creates what kind of moment about E? Negative. So that's 100 kips, and it has a force of 30 feet. So it looks like dy is going to have the right, it's going to be positive, so I chose the right direction. And what's the answer? 150? Is that right?
Yeah.
150 kips. Now you can do whatever you like. Well, not true. You can't do whatever you like. In a statically determinate sense, you can do in that you can sum forces in the X direction or sum forces in the Y. It doesn't really matter which one you do first. So I'll just do it in the Y direction. So summing forces in the Y direction, what do I have? When I look at my free body diagram, I've got EY and DY. They're both acting up. That's positive. So there's GY plus EY. And then what else do I have? That's it. So it looks EY is just going to be equal to minus DY, which is equal to minus 150. And then last, I can figure out my X reaction at E by summing forces in the X direction, making sure that's in equilibrium. And what do I have? Let's see. I've got EX acting to the right. That's positive for my sign. And my 100 kip force is also acting to the right. That's also positive. So that's not a difficult equation to solve for. So it looks like EX is going to be minus 100 kips. Okay? So we got that. Now what do we do? Let's go back and look at the original truss and see where we should start. Just exploring opportunities. Let's start at A. Could I go to A and do a method of joints there? Well, sure. There's two unknowns. I can write two equations and two unknowns. But A is something special. What is it?
Zero force.
It's a zero force member. And that would be our case one. that we talked about in class earlier. So I'll just label that as case 1, and because of that, I know that the force in AB is equal to the force in AE, and it's equal to 0. And just to help you visualize that, I'll just go ahead and put a couple of zeros there. They're not there. So if you're designing this truss, and you'll never have a load system where you apply anything at A, then you might want to think why you have these elements here. They may not be important to you. And the reason I'm pointing that out is pretty soon we'll be moving into our first project, and you'll be designing a truss, and part of your objective will be the cost and the weight of the system. And if you have extra elements that aren't doing anything for you, well, that's additional cost and additional weight, and that will work against you. So just keep that in mind. We'll talk about that in a little bit. All right, so now I just got to do these last. Let's see, I got 1, 2, 3, 4, 5 elements. So where could I go? Let's just go alphabetically. Could I go to B now and solve for stuff at B?
Yes.
Well, I got 1, 2, 3 unknowns. How many equations can I write?
3.
2.
Oh.
2 in a joint, right?
Oh, yeah.
So that's probably not a good place to start. Let's see, A, B, C. Could I go to C?
Yes.
Yeah. I got 2 unknowns, 2 equations. That's a good place. Could I start at D? No. 1, 2, 3 unknowns, only 2 equations. What about E?
Yes.
Yeah, E's a good place because it looks like you have 3, but remember, we've already found 1 is 0. So there's really just 2 unknowns and 2 equations. So I would probably start at E, C, and E, and then once I get the parts I need, decide whether to finish off with B or D. And to be honest, probably E is the easiest one to do, so I'm going to start there. So I'm going to I'm going to draw, not write. I'm going to draw my free body diagram for my joint at E. So there it is. First, I'm going to put on the forces that I know. I know EY. EY I assumed was up, but it came out negative, so it's actually down 150 kips. And EX I assumed was to the right, but I got a negative, so it's actually to the left, and that was 100 kips. So there's the 2 things I know. And now I'm going to assume tension in the force DE, and I'm going to assume tension in the element BE. Now hopefully you can see that when you're looking at that, that's a pretty easy set of equations to write. When I sum forces in the y direction, I only have 1 unknown. When I sum forces in the x direction, I only have 1 unknown. So that's going to be pretty easy. So we'll just do that real quick. So I'll sum forces in the y direction. I'll assume up as my positive sign convention. We'll make sure everything's in equilibrium. So looking at stuff acting up, I've got the force in BE, and I've got my reaction force acting down, so that'll be minus 150 kips. So again, that's not hard to solve. The force in BE is 150. Positive force means what? Positive result means what? What kind of force did I assume? Tension. So it's going to be in tension. So let's get the x component. So we'll sum forces in the x. I'll assume to the right is my positive sign convention. So I've got my unknown force acting to the right. So that'll be positive, the force in DE. And then also in the x direction, I've got this 100 kip force, but it's acting to the left, so that's going to be negative. Again, not a difficult problem to solve. So we now know the force in DE is 100 kips. So both came out in tension. Does that make sense?
Yes.
Well, let me just kind of cover this part of the truss up to kind of get it out of your mind. Now, if I pull, the only thing on this force is a horizontal force to the right. So what's going to happen to D? Is D going to move left or right? It's going to move to the right. So that means that DE is going to get longer. That means it's in tension. At the same time, what's going to happen? How is this structure going to move about D?
Clockwise.
It was going to try to move clockwise, which means all these elements here are probably going to stretch, which means they'll be in tension too. And we just found out that BE was in tension. So that seems to be reasonable so far. So there's my joint at E. And I won't put 0, but I'll now put a little mark through there. I know those values. So I'm down to just knowing 3 things. Now, you could go to B, because now there's just 2 remaining unknowns. But if you look at B, both my 2 remaining unknowns have X and Y components. That means you probably have to solve those simultaneous. Probably not something you want to do routinely on the test. If you jump over here to D, what happens? Well, again, only 2 unknowns. One of them just has an X component, so that's pretty good. So D probably looks like a better choice than B right now. But what about C? Yeah, C is the same characteristics as D, except it doesn't include anything I've calculated before. So I think C is a safer bet. It's not including anything that I've calculated before. I'm going to go up to C, and I can find BC and CD without using any of my previous values. So that's probably a safe thing to do. Independent verification. So let's go to the joint at C. So I'll draw that. I'll put on the external force that we have. That's 100 kips. And then I will assume directions for my bar forces. So tension in CD and tension in BC. And what is the slope of that element? Well, it looks like this element here has a run of 40 feet and a rise of 30 feet. So that's a 3, 4, 5 triangle again. How convenient, huh? So that would be a run of 4 to a rise of 3. Now I have 2 equations. I can sum forces in the x direction. I can sum forces in the y direction. Which one should I do first? X. Only one of my forces has an x component, whereas they both have y components. So it'd be better to sum forces in the x direction. So that's where I'll start. So I'll assume positive is to the right, and then I'll sum all my x components. So looking at the x components, I've got the force in BC. It's actually to the left, so that will be negative. And the x component will be 4/5 of BC. And in the x direction, I have the applied force to the right, so that's positive. So it looks like the force in BC is going to be positive. We already talked about that before, being in tension, so that's good. It looks like it's going to be 125. Does that look right? Yes?
Yes.
And now I can finish off my equilibrium by summing forces in the y direction. Now I'll have to include my result for BC. That one is going down. The vertical component is the 3 to 5, so that's minus 3/5 of the force in BC, and also minus the force in CD. So it looks like CD is going to be negative, and it's 75. Does that sound right?
Yes.
So CD is the only compression force in here. And that kind of makes sense too. As you pull this to the right, the whole structure is trying to rotate clockwise. It makes sense that C would not go up. It would probably try to move down, and that would compress CD. So now I've got this one and this one. I only have one left, right? That diagonal right here. How best to get that? Yeah, I'm still not liking B. You know, I think D might be the way to go. So I'm going to do that. I've run out of paper, so I'm going to flip this up and finish here. So I'm going to write my joint at D. So here's D. Now what do I know at D? Remember I solved for dy and I got a positive 150. So that will be acting up. And that was Kipps. Also at D, I have force acting up. That would be the force in CD. I have a tension force, or I'm always assuming tension. That will be the force in DE. And then the one I'm missing, this guy, this is the force in BD. Now let's take a second and examine its slope. So in this case, this element looks like it has a run of 20 and a rise of 15. Divide by 5, you still get a 3, 4, 5 triangle. Now just to remind you, we've already solved for CD, so I know that one. We've already solved for DE, so I know that one. So what's the path of least resistance to get this one? I don't think it matters, but maybe summing forces in the X, because it only includes one computed value, whereas if you sum forces in the Y, you have two computed values. It's a very minimal, very fine line. You could go either way. I'm going to go with summing forces in the X. So when I do that, I have the force DE to the left. That's negative in my sign convention. I have the X component of BD also moving to the left. And the X component will be 4 over 5, or 4/5 of BD. I think that's it, isn't it? I think so. So solving for BD. Let's see. What did I find for DE before? I think it was positive 100.
Yep.
So I plug my positive 100 in there, move it to the other side. So it looks like BC is going to be negative. And 125?
Yep.
Now these are a little harder to make sometimes view, this diagonal confirming that it's in compression. But I think our general idea that we had before is that as this structure tries to rotate clockwise, all these elements are going to go in tension. It seems reasonable that these would be in possibly compression.
Dr. Kemp,
Yes?
should be BD on BC.
BC should be BD. Right here? You mean that?
Yeah.
There's no record to indicate that there was a C there now. Except on the video, which I'm sure you'll never watch.
That's what a Q is.
It looks like a Q, a BQ. Maybe I should have put another B there and it could be BBQ. And we could all be thinking about lunch.
Let's do that for ribs.
So any questions about that?
No.
That took 19 minutes to work. But I was talking about barbecue and doing other things. So I think that's a reasonable problem to ask you to do on the exam. Because you would probably not be talking, hopefully to your neighbors, and you would focus and save you some time. Generally, there's about 15 minutes per problem on the exam, so it's a little bit over. But I think it's reasonable. So any other questions about that? All right.